So, you know, I look at this one and I wonder, no, maybe you could factor out a 2 here. So let's go ahead and show some division here. Let's see if I can get the technology to help me on this one, though. Okay, so that's our dividend. Again, that goes into the divide symbol. I'm okay with that. And then the denominator here is on the outside of the division. Now again, you know, we look at this and in this unit, we get so used to factoring, it's like, let's factor out a 4 right here. Again, I just don't know what it does for us. In fact, I don't think it does anything for us. So I'm not going to, okay? What I do notice is that 28, 148, 156, I believe are all multiples of 4, which is convenient, at least. So here, again, I'm looking at the 4x. We'll apply whatever the quotient is here to the 16, but I'm just focusing on the 4x and the 28x to the power of 3. So I like to start with the letters. You can start with the numbers if you'd like. So for this one, you'd say, here I have an x, but I need 3 of the x's. So that means I need 2 more x's. That's x squared. Okay, so the x squared times the x, that will make it an x cubed right here. And again, so now we got to work with the numbers, right? So I got to make the 4 28. How will you make a 4 28? Again, with multiplication, you'd have to multiply 4 by 7. So 7 times the 4, that's going to be 28. That's what we're taking away. And again, it's not complete because now I've got to multiply the 7x squared by the 16. That's going to give me some number of x squared. But there's my calculator. 7 times 16, 112. So we used up, so that's minus 112. Now again, is it, how do we know that there's a positive 7? It's because it was a positive 28 there, okay? So by subtracting, we have now zeroed out our 28x cubes, and then I got 148 minus 112. Yes, I did put that in the calculator because I don't trust myself this early in the morning. But I get 36x squareds from that. Everything else drops, and this gives me a new expression to work with, 156x, and then plus 39. I didn't check this in the beginning. I guess I've kind of got used to it, but this was already in descending order, by the way, so we didn't have to actually rearrange the order. Okay, so I got 4 x's. Again, we'll apply the 16, but the 4 x's and the 36 x's. It's missing an x from there, so x times x, that would be x squared, but we need 36 of them. And since the 36 is positive, I'm expecting a plus sign there. What do I got to multiply by 4 to get 36? It's old 9er. 9 times 6 is 36, but we're going to take that away. Okay, so that's going to zero that out. Then I got to do 9 times the 16 as well, 9x times 16, which would be 144 x's also have been used. So that zeroes those x squareds out as planned. I got 156 minus 144, I believe that's 12 x's. And then we'll drop positive 39. Now, 39 is not a multiple of 4 or 16, so I am expecting some amount of remainder on this. But first, again, I already have an x with my 4x, so I don't need to multiply by another x here. But what I do need then is I need to multiply 4 by something to get 12. And the 12 is positive, so I'm expecting a positive number here. It's going to be 3. 3 times the 4 x's would be 12 x's. Again, we've used those up. So then 3 times 16 is 48, but again, those have been used up. So it looks like we've zeroed out the x's as planned. 39 minus 48 is negative 9. Again, well, that's my remainder right there. Remainder of negative 9. I'm going to change that color because it's kind of a different part there. So what is our final answer, our quotient? Well, it was 7x squared. I can usually do better 7 than that. Oh, crap. There it is. 7x squared, positive 9x, and then positive 3. But then we had a remainder of negative 9. And again, I'll show this both ways, again, because it may ask for either one. But then you'd add, well, I guess it'd be, you could say plus negative 9, I suppose. That'd be over whatever your divisor was in the beginning, 4x plus 16. Either one of these work. So I know this is only our second problem, but you may have noticed that these, since this was in descending order, our quotient ends up being in descending order. And while this is just an x, we end up just kind of having one less x, one less x, one less x.
Wouldn't it be